This is the second part on my coverage of the autonomic nervous system. The first part focusing on the anatomy, and this focusing on the physiology and the function. And so in my class, I would begin, imagine that on your way home, you see something like this in a park near your house. Well, this is a problem. And obviously your response in the next, 10 minutes or so, this could be important in your life. And so when we think of your guts, and remember that the autonomic nervous system is in charge primarily of the guts, blood vessels, the heart, the respiratory system, digestive system, etc. It's important that they all act together. So for example, let's say that the heart knows it's an emergency and starts to beat really fast. Well, that's good. But the lungs have to know it's an emergency too, because they have to dilate the respiratory passageways so that more oxygen can come into the body and increase breathing rate so that there can be more oxygen in the blood. We want to beat and send the blood towards the muscles, but it needs to have oxygen in it. If not, then the purpose isn't achieved. And so therefore, the lungs have to be in on this as well. This oxygen is designed to help break down energy molecules like sugars and fatty acid byproducts for energy so that, say, muscles can run, so you can run away from the lion or fight. But that means that, the liver and fat cells have to be in on this too. They have to know it's an emergency because the liver is storing glycogen, adipose is storing triglycerides. If they hold on to that, then the muscles, they have less to break down for energy. So they have to know that it's an emergency so they can produce energy-rich molecules in the bloodstream. The blood vessels have to be in on this because let's say you put energy molecules and oxygen into the blood, and then blood vessels divert this blood to go to the spleen. If you see a lion and want to save your life, how is sending blood to the spleen going to help you? It's not. And so that's why the part of the nervous system which services the guts, the autonomic nervous system, has these two modes, as was covered in the previous lecture. The first is what's called the sympathetic division. Its preganglionic neurons originate in the thoracic and lumbar sections of the spinal cord. And as covered elsewhere, also it will send some neurons to the adrenal medulla, which then stimulate the release of epinephrine into the blood. So this division, the sympathetic division, not only sends neurons which touch various organs, but also puts epinephrine into the blood where it acts as a hormone, reaching cells throughout the body, even the cells that neurons don't touch. And so this then governs the fight or flight response, so that now all of the organs are aware it's an emergency. And so the heart knows it, the lungs know it, the liver, the fat cells, the blood vessels, etc. And so then we can have this coordinated response to this, because it does not help us if the heart thinks it's an emergency and the lungs don't, or the blood vessels are sending blood away from skeletal muscle cells. And so that's the importance of the guts having these two modes of the autonomic nervous system, one for emergencies, one for rest. Okay. Now, the stresses that our ancestors faced, as I will discuss later, was more on that line of potential predators or trying to hunt something for food, things which would be dramatic and relatively short in their duration. And so that mode, the sympathetic division, was meant to deal with these short-term stresses. And then otherwise, you were meant to engage the parasympathetic division, also known as the rest and repose division, so that your heart rate, your breathing can all decrease. And when we are at rest, this is when we can then, digest our food, send energy to our immune system, etc. Now, let me just go through all of the responses, one by one. First, Our ability to clot our blood then depends on clotting factors, which are in the bloodstream. And we can vary our levels of these. Some individuals, their blood clots rather quickly because they have higher levels of clotting factors in their blood. Well, in response to an emergency, we can increase levels of clotting factors in our blood, which would then allow our blood to clot more quickly, which would be an advantage if, there's a wild animal which we are wrestling with, etc. Obviously, if we're going to have to run very fast, we're going to run the risk of overheating. And so the sympathetic division will then also stimulate sweat glands to release watery sweat to cool our bodies down, allowing us to run farther, etc. So these would be part of the sympathetic response. In the sympathetic response, once again, maybe we're exercising or maybe there's an emergency and we have to run or fight, it will increase heart rate and also the strength of heart contractions. This plus the vasoconstriction of blood vessels will raise blood pressure as well so that we can get more blood to muscles. The sympathetic division can do this because not only do nerves go and touch the parts of the heart which are determining the pacemaker activity, so reaching the SA and AV nodes through these cardiac acceleratory nerves, but also, as I covered in the previous video, epinephrine can be released as a hormone from the adrenal glands, which lie over the kidneys. This then can reach the heart as well. So, there are actually two separate sources of the same signal telling the heart then to beat faster, which is good. That's what the muscles need in an emergency to get more blood to them. Now, at rest, we don't need this. And having high blood pressure and a rapid heart rate when we're at rest, this is actually unhealthy. And so the parasympathetic division then decreases heart rate. Through the cranial sacral division, the vagus nerve reaches out and contacts the heart, where acetylcholine then reaches those pacemaker areas and decreases heart rate. So the parasympathetic division will lower blood pressure, will lower heart rate and the contractibility of the heart, the force of its muscle contractions. Once again, that idea of dual innervation, and that the heart doesn't, just rely on only the sympathetic division or the parasympathetic division. Both of these divisions offer dual innervation. The sympathetic division can speed up the heart. The parasympathetic division can slow it down. The lungs receive input from the autonomic nervous system. Our breathing rate can increase. We can increase the number of breaths we take per minute. We can increase our tidal volume, how deeply we inhale. And then we can also then have bronchodilation. Just as blood vessels can constrict and dilate, so too can our respiratory system. So we can have bronchodilation, where our respiratory passageways let in more air. We would see the reverse in under parasympathetic stimulation. So when we're at rest, we don't want to hyperventilate. That would actually be bad and predispose us to alkalosis. So, if you don't need to, you don't need to be breathing like that. So the parasympathetic division would tend to slow down respiration and the depths of our inhales. The digestive system certainly is capable of digesting food, but this takes energy and it takes blood, all right? And so when digestive organs are, active, there's gastric motility, where, muscle contractions are spreading in waves over the stomach or over the intestines. They're using body's fluids to create gastric juices, etc. A lot of the blood is going to the small intestines so that we can absorb nutrients and the like. Well, during an emergency, that's just something we can't afford to do. The muscles need our blood. Once again, perhaps even 10 minutes or so are going to, determine whether we survive this emergency or not. So under the direction of the sympathetic division, less blood flow reaches the digestive tract. Gastric motility and secretion would decrease. We would make less saliva. Once again, we shouldn't be trying to eat when there's an emergency. And so our digestive system works best under parasympathetic stimulation in the rest and repose mode. That is when the gastric motility and gastric secretion can reach its maximal level. That's when we're making saliva. That's when blood is reaching the intestines again. So digestion, this is something that we do best in our under parasympathetic stimulation. And so this then would affect other areas as well. So in general, our skeletal muscles are receiving more blood flow under sympathetic stimulation. And so that's, a concept for, discussion blood vessels. In your body, you have 5 liters of blood, but you have 8 liters of space. So you do not have enough blood to send blood everywhere and fill blood vessels maximally. And so every second of the day, you're making decisions. Do I send blood to my skeletal muscles? Well, during an emergency, that's what you want to do. So more blood does go to your skeletal muscles. As opposed to, as I had just said, in parasympathetic rest and repose mode, we would send blood away from our blood vessels. So just as blood vessels, as I mentioned, can constrict and dilate, and we can call that vasoconstriction. And vasodilation, the same thing can happen in the lungs with respiratory passageways, bronchoconstriction and bronchodilation. We vary whether we are storing glucose in our liver or releasing it, or whether our fat cells are breaking down triglycerides so that fatty acid byproducts can enter the blood. And so obviously that's, breaking these down and putting them in the blood. That's something we want to do when we need it, say, during an emergency. Your immune system can receive a large amount of blood, like the spleen can hold a large quantity of blood, but it doesn't have to. And so we can direct our body's resources to screening the body for infection, for screening for cancer cells with the immune system, but we don't have to. And so once again, that's a choice. How much, blood, how much of, the body's resources is going to these immune cells. Are we encouraging, their division or not? At rest, your kidneys, which are filtering the blood to remove nitrogenous waste, like urea, that can receive at least a fifth and maybe a quarter of the blood that leaves your left ventricle. That's a lot of blood. A quarter of the blood leaving your left ventricle can go to your kidneys. During an emergency, that's too much. You want your blood to be going to the muscles, which are helping you to run or to fight. And so under the sympathetic stimulation, less blood would reach the kidneys to be filtered. But because we do want to remove these nitrogenous waste, it would then be that when we're at rest, using the parasympathetic division, that we would then be using our sending more blood to our kidneys to be filtered. Okay. The reproductive system not only requires blood for its function, so for example, for a man to achieve an erection or for a woman to lubricate the vagina, blood has to reach the reproductive structures, but then also we can vary the degree that sex hormones are made, the degree of sex drive, etc. The sympathetic division would tend to tamp down on this because once again, if you were running for your life, noticing how attractive your partner is, well, that's just not helping you at this moment. And so the sympathetic division would send less blood to the reproductive system. and then decreased production of steroid hormones, where under the parasympathetic division, the reproductive system could receive the maximal amount of blood supply and body's resources. Okay, so the body's guts, the blood vessels, the lymphatic structures, the immune system, etc. They are dually innervated. All right, so they are receiving commands from both the sympathetic division under stress or during exercise. Here you see vasoconstriction. There's a blood vessel lining, which is or blood vessel wall, which is going to constrict. And they receive commands during the parasympathetic division as well. So this all makes perfect sense, but there's a but. So if we think of what stress means, just to reflect back, the definition of stress has changed. So humanity is quite old. The first members of the genus Homo go back 2.5 million years. Here's Homo erectus, perhaps from 1.5 million years ago. So that's a really long time. Our species, Homo sapiens, has been around for a couple 100,000 years. And when we think of what stress has typically meant, typically it has been, we're going to have to run a great distance from something which is chasing us. We have to fight a big wild animal or hunt a wild animal for food. Now, one of the features of these stressful events is how short they would last. Once again, if you were to encounter a wild animal in a park on your way home, one way or another, this resolves itself in a short period of time. All right, and so when you think of what these individuals face with these wild animals, the sympathetic division's responses certainly make sense. So, for example, if you are going to, however, as I'm focusing on here, the problem then comes, we live in a modern world. Meeting wild animals on our way home is less of an issue. But instead, stresses now are things like a stressful time at work, the end of the quarter when the budget is due, finals week for students, an accelerated nursing program, et cetera. Difficulty in relationships or at the job with a difficult boss. These are not things which last 10 minutes and then are resolved. Instead, this can go on for a long period of time. That then becomes a problem because the fight or flight response, the sympathetic division, was meant to be engaged for those short-term stresses. What stress used to mean for our ancestors. If you use this ancient system for modern stresses, which can often be chronic, very long, all right, then it's no longer helpful. Releasing glucose and fatty acids into the blood, that's certainly good if you need, to run from a bear. But let's say, you're doing something like, writing a term paper. Well, that's a problem because now you just have more glucose in your blood than you need. You don't need that much energy for writing the term paper. And now you're running the risk of gaining weight as we look at chronic stress, of worsening atherosclerosis, as the fatty acids can contribute to lipid plaques. If you're overproducing the amount of diabetes, you then have to overproduce the amount of insulin to make it go down. You're overproducing the amount of glucose, which predisposes you to diabetes. So there is a downside of using these responses in modern stresses. It makes sense fighting the lion to increase the number and strength of heart contractions, to increase blood pressure and the like. But if this is simply, a difficult meeting at, work that you are getting for, then that's not helpful. It makes sense to increase the number of clotting factors, making your blood thicker, more likely to to clot if you're wrestling with a wild animal. But if it's just a modern stress that you're dealing with, well, blood clots now increase your risk of heart attack and stroke. All right. It makes sense that if there's an emergency, that you don't digest your food. Digestion is important, but not now. Making urine is important, but not now. Fighting a flu and screening your body for cancer is important, but not now. Being potentially interested in your partner is important, but not now. And it certainly makes sense that during a short-term stress, that we divert blood and energy away from the digestive system, urinary system, immune system, reproductive system, etc. The problem then comes if you're under chronic stress, if it's a difficult time at work. Well, then you're now having digestive issues because you are, for long periods of time, directing blood away from your digestive system. You're more likely to get sick. Many people, after a stressful time, they get sick because during that time, they weren't giving the immune system the resources in the blood that it meant to that it needed to function optimally, and thus, as a result, then an infection is more likely to spread, or cancer might take hold. Many individuals in stressful times then have relationship issues. But one of the factors is under chronic stress, you are less interested in your partner. Your libido goes down, you're making fewer steroid hormones. But then also, if less blood is going to the reproductive system, because under stress, we literally direct blood away from our reproductive system, then a man would be less likely to maintain an erection, a woman less likely to lubricate the vagina. So being physically together with a partner becomes more difficult. And then other things as well. If you are under stress, you're going to look tense because you're getting ready to run or to fight. You're sweating because now you're getting ready to lose heat. But if you're preparing for a speech, looking tense and sweating in your nice work clothes, etc., this then is a problem. The sympathetic division does other battle prep. So in an emergency, you could make more endorphins so that you didn't feel pain as much. If you had to sprint, you might urinate or defecate very quickly, just to become lighter and able to run faster. One final thing here is, let's say you were going to give a speech. We know that under stress, we direct blood flow away from the salivary glands. We make less saliva, and so a lot of people, if they're nervous about a speech, then this would affect. This then gives them a dry mouth and makes it more difficult, to have that speech. One thing that we don't, entirely understand, but is the relationship between, chronic stress and illness. But here's, something where the autonomic neurons, they have these unique synapses where there's these continued swellings that can release neurotransmitters. And white blood cells are often found in the vicinity, and white blood cells make receptors for these signals. So when we make, depending on whether we're under stress or not, our immune system responds to that. They pick up on these signals. And in the same way, the immune system can actually talk then to the nervous system as well. And so there is that connection between the nervous system and the immune system. One of the videos in my playlist is more humorous. It was meant to have these two superheroes, sympathetic woman and parasympathetic man. And then, my students, then say, like, during, specific instances, which of these superheroes would you call? And obviously, so these individuals in an emergency, if they're running away from a dinosaur, they need then the sympathetic division, while someone who wants to relax after a tough day at work would then need the parasympathetic division. Right. So then, in summary, your nervous system controls your guts. And in general, you want your guts to be working in kind of two different modes. Either you're exercising or it's a potential emergency, all right? And thus everyone is on the same page. Once again, if there's an emergency, if your heart knows there's an emergency and your lungs don't, this isn't, very effective. So all the guts have to be on the same page. So the sympathetic division would govern that response, as then opposed to, at rest, the parasympathetic division engages that. And an important point is, if we consider modern healthcare and problems that patients have, many patients then have problems which stem from an overuse of the sympathetic division, these modern stresses, which are prolonged and can lead to chronic stress. This then causes multiple effects throughout the body, which were unintended. The sympathetic division was meant to deal with short-term stresses. And in the modern world, the nature of stress has changed, which means that our response to stress is less adaptive and can contribute to heart disease, to diabetes, to heart attack, to stroke, and to other problems.